midnight over the Pacific. A pilot glances at the standby compass, one more instrument in a modern cockpit, and notices a slow, stubborn drift away from the flight management system's track. In a control room half a world away, a space weather technician watches a world map where the magnetic North Pole has been creeping across the Arctic for decades and sees it accelerate. Phones buzz. A terse bulletin goes out to observatories and satellite operators. The dipole moment, the strength of Earth's planetary magnet, has plunged faster than models allowed. The field is breaking into knots. Hour 1. Natural hazards do not wait for human comfort. Magnetometers from Greenland to Antarctica record wild deviations as the smooth bar magnet pattern that usually threads the planet fractures into multiple lobes. Compasses in high latitudes swing away from Canada and Siberia toward transient local poles. Smartphones that rely on magnetometers for heading lose their cool. Maps jitter on long exposures. Developers push emergency updates to weight GPS and gyros more heavily. A whisper appears in auroral cameras normally trained on the far north. Curtains of green light snaking farther south than they should. An early sign that charged particles are finding easier paths into the upper atmosphere along tangled lines. Hour 2. Shipping lanes take it in stride at first. Modern navigation rides on inertial sensors, satellite timing and radar. But tug captains in harbors that still use magnetic bearings to align approaches call dispatch with one-sentence reports. The card is wrong. In a rural field, a researcher who trains homing pigeons scratches out a planned release. On these days, birds sometimes circle aimlessly, the instinct that points them home jammed by new magnetic maps. In the South Atlantic, where Earth's field is already weak, the South Atlantic Anomaly, low-orbit satellites take extra radiation hits as belts of trapped particles dip closer to the atmosphere. Engineers who thought they had years to replace certain boards move a deadline to yesterday. Hour 3. Radio operators hear the ionosphere shuffle its deck. High-frequency, HF beams that normally bounce cleanly between layers of charged gas and the ground to cross oceans now scatter in odd directions as those layers wrinkle. Polar routes, airline corridors that thread close to the poles, see patchy blackouts in voice and data links that use HF as a backstop. No emergency. Aircraft carry multiple options: satellite comms, VHF relays, inertial navigation. Dispatchers reroute a handful of flights to lower latitudes as a precaution, burning extra fuel in exchange for certainty. Hour 4. Newsrooms wake to the phrase magnetic field flip and jam it into headlines. Physicists flinch. A true reversal, the north and south magnetic poles swapping places, takes thousands of years and leaves a sedimentary record in cooled lavas and seafloor stripes. What is happening now is an excursion, a rapid, deep dive in the field's organization that can precede or mimic a flip at the surface. It is rare on human timescales, but not mythical. The Laschamp excursion, about 41,000 years ago, saw the field weaken dramatically for a few centuries and smear the aurora across latitudes that rarely see it now. The world did not end, it changed the rules at the edges. Hour 5. In zoos and labs, animals with magnetoreception fail quiet tests. A loggerhead turtle in a rehabilitation pool that normally orients consistently toward the virtual magnetic signature of its natal beach, faked by coils around the tank, stops showing a preference. In a dark tent where researchers study how migratory birds use polarized light and weak magnetic cues at twilight, the birds twitch, then settle in the wrong quadrant. This is not mass panic. It is the loss of a subtle compass that many species layer on top of star maps, smells, and landmarks. In the wild, some will adapt, delay, or default to other senses. Others, mid-journey and low on fat, will risk a turn in the dark. Hour 6. Finance and social media discover each other's limits. Stocks tied to airlines and satellite communications dip, then rebound on statements that flights are safe and redundancy is working. Conspiracy channels ignite with claims that a flip means an apocalypse, volcanoes, tsunamis, chaos. Geologists breathe and repeat the facts wherever someone will listen. Magnetic field reorganizations are note earthquakes, not tides, not weather control. Gravity moves oceans, heat and water move air. The core's dynamo draws curtains of charged particles and paints auroras. Our protection from the sun's wind is not gone. It is dented, complicated, and likely to stay that way for months. Hour 7. The Northern Lights stroll down across Canada and the northern United States like a guest who decided to sit in the front rows. In Europe, the same happens across Scotland and northern Germany. Cameras, then eyes, catch it as twilight fades, green and violet veils over cities that rarely see them. Power grid operators glance at monitors that track geomagnetically induced currents, slow, DC-like flows that can saturate transformers during strong solar storms. Tonight is quiet. The sun's output is normal. But a weaker, lumpier magnetosphere means that when a big coronal mass ejection does arrive, more energy can couple into the ground. Playbooks are reviewed, schedules shifted, maintenance is deferred, extra staff assigned to midnight shifts, backbone lines watched. Hour 8. A fishing fleet off Chile that still teaches navigation both ways, with GPS and with compass and bearing triangles, runs a drill. Secure GPS, dead reckon. The exercise is not theatre. When constellations are healthy and the ionosphere is stable, satellite navigation is near magic. But in heavy scintillation, the twinkling of radio signals through a churning ionosphere, positioning can jitter. Good seamanship never treats any single instrument as holy. Hour 9. In a lab underground, someone runs an old experiment with new urgency. Neutrons through rock record cosmic rays, which grow more numerous when Earth's magnetic shield weakens. The count ticked up days ago. At ground level, the dose is still small compared to normal background beer and bananas. At altitude, on polar airline routes and in high-latitude latitudes, crews and frequent flyers will take an extra fraction of a millisievert if this holds for months, the kind of number regulators track and manage by adjusting routes and altitudes. Radiation safety teams pull up software that estimates dose by flight path and solar conditions. Pilots will see a few more, avoid blue, stay low, route south in their flight plans when storms erupt. Hour 10. Outside town, a Boy Scout troop with paper maps and silver compasses does a day hike and learns something you could not teach last year: declination. The angle between geographic north, where maps point, and magnetic north, where compasses point, has swung so far overnight that the standard local correction is wrong by degrees. Their leader pulls out a two-way radio to call the park station and gets the updated declination from a ranger. The lesson is not that compasses failed. It is that some days you must be smarter than your tools. Hour 12. A worldwide network of observatories that watch Earth's magnetic field every second releases the first global maps of the new chaos. Where there were two poles, north and south, there are now a handful of strong lobes and a smear of weak zones, most infamously the South Atlantic Anomaly and its sibling blooming toward the Indian Ocean. Submarine crews, which still train with fluxgate magnetometers, to hunt anomalies in the sea floor, pull fresh tables for declination and inclination. Oil and gas drillers who use magnetic surveys to aim well bores adjust their software. Archaeologists quietly smile. The same techniques that will keep drill bits straight let them date ancient hearths and pottery by reading the magnetization baked in clays. The world's confusion today will be tomorrow's timestamp in fired brick. Hour 14. A routine, medium-sized solar flare launches a coronal mass ejection into space. It is not aimed at Earth. If it were, operators would want the interplanetary magnetic field to point north when it hit. North-north is safe, south-north is dangerous. Nobody can steer the sun. They can watch ACE and DESCO VR, monitors parked sunward at L1, to read the field hours before it arrives and prepare. With a scrambled magnetosphere, operators will need to be more conservative, acting on smaller alarms. Hour 16. The first confident public explanations land and stick. Earth's field is generated by a dynamo, liquid iron and nickel in the outer core, convect and shear, charged motion making magnetic loops. The simplest state is a strong, mostly dipolar field, like a bar magnet, tilted a bit from the spin axis. Over centuries, patches of the core where the field is generated, flux patches, can grow, die, and move. When enough patches compete, the field at the surface can look messy, multiple poles, weak zones, wandering directions. Sometimes, over millennia, this chaos resolves into a reversed orientation. Sometimes it returns to the original. The rocks keep score. Humans do not usually get front row seats for the opening act. Now we do. Hour 18. People ask if birds will fall from the sky or whales strand in flocks. The answer is annoying. Some will make mistakes, most will not. Migration is multimodal. Birds use stars at night, the sun by day, polarized light at dusk and dawn, landmarks, smells, winds, and an inner compass in their eyes, a protein named cryptochrome that changes chemistry when light hits it in a magnetic field. When the field goes strange, birds get worse at long open water crossings and better when the sky is clear or the ground familiar. Whales and dolphins may make more navigation errors near coasts where magnetism, bathymetry, and currents all give cues. Strandings rise after solar storms in some studies, but parasites, noise, and prey matter too. Nature rarely writes with one pen. Hour 20. A room of programmers tired of plot heat maps switches to writing code that will matter. Adaptive filters for satellite navigation that downweight magnetically induced ionospheric noise. Firmware that tells small satellites to safe their sensitive instruments when the South Atlantic Anomaly bulges overhead. Alerts for airline dispatch that combine space weather forecasts with probabilistic track planning. This is where civilizations earn their calm, not in speeches, but in boring patches rolled to production. Hour 24. One day in, the world remains intact. Auroras glow at lower latitudes. Compasses where you live may lie by 10, 20, 30 degrees. Runways do not get renumbered. Those decisions are slow, measured in years, but pilots get a no-tam packet with caution flags. The ISS crew sees more particle hits than last week. A few small satellites report bit flips in their onboard memory and reboot with a shrug. Social feeds stretch flip into panic and back. Scientists go home and sleep 3 hours so they can live at the lab. Day 2. The news cycle drops most of its cartoon apocalypses and picks up real puzzles. If the field holds this week, will climate change? Not on human schedules. The magnetosphere does not hold the atmosphere in place. Gravity does. It does not steer weather. The sun and ocean do. But in bouts of high solar activity layered on a weak field, ultraviolet and X-ray bursts can peel away a little ozone at high latitudes for days, letting more UV reach the surface in the far north and south. That's a sunscreen story, not a crop failure. In the long run, on mega-year scales, the magnetosphere can affect upper atmospheric chemistry and perhaps, with help from the sun's mood, trickle energy into climate. That long run will not arrive this week. Day 3. Deep interior specialists publish their best models yet, calibrated with the gusher of data from thousands of ground stations and dozens of satellites. The core under Africa, the African Large Low Shear Velocity Province, a mouthful that means a blob where seismic waves slow, has long been suspected of interfering with the geodynamo, and the South Atlantic Anomaly drifts above it. Drivers, in other words, live deep. Hot plumes, compositional quirks, flows that twist field lines. Nobody can see the core directly. They can invert seismic waves and magnetic field snapshots to reconstruct a movie, and the new frames are stunning. A dipole crumpling not into collapse, but into a parent with unruly children who fight for attention. Day 4. In high schools, teachers bring compasses to the track and draw circles that mark where north points, then repeat at lunch and after school to watch the arrow swing. The demonstration lands. Teens who thought science was a list of facts realize they're standing in a chapter that is still being written. Follow-on labs pop up online, a DIY magnetometer built from a CD and a laser pointer to watch local field strength, a homemade coil and audio jack to hear the spherics of lightning in the very low frequency band and how they change as the field shifts. Day 5. Telecoms push patches quietly. Undersea cable repeaters carry timing signals that can be affected by space weather and magnetic induction indirectly through power systems. GPS-disciplined oscillators that keep small cell towers in step are told to trust their local quartz when the ionosphere is a mess and to vote among multiple satellite constellations, GPS, Galileo, Beidou, GLONASS, rather than hitched to one. Timing is where modern life hides, in 5G handoffs, in stock trades, in TV streams. The weaker magnetosphere forces timing engineers to show off their redundancy. Day 6. A boutique watchmaker sells out of mechanical compasses engraved with the phrase "Trust but verify." A hobby with 1,000 years of history, celestial navigation, trends among sailors. The romance is misleading. Even in this mess, GPS will work 99% of the time. But having an off-grid way to know where you are never stopped being cool. Day 7. The first big solar storm of this episode arrives. Hours earlier, a monitor at L1 measured the interplanetary magnetic field turning south, bad, and the speed high, worse. Grid operators had hours to prepare, open loop switches to reroute risk, bring extra reactive power online to keep transformer cores happy, reduce flows on long east-west lines that couple more energy, staff substations, top up diesel at peaking plants in case. Airlines already sent polar flights under the auroral oval and down the spine of continents. The storm splashes across the new stratified magnetosphere like a wave into a beach with strange rocks. Auroras paint Florida and Sicily. A transformer in a lightly loaded rural substation trips into a protective shutdown and is inspected by dawn. It was fine, the system cautious. A handful of satellites go silent and reboot. ISS alarms go off. The crew closes hatches to shield themselves in the service module during the worst few hours. News tickers run B-roll of power lines in the wind. The operators go back to drinking coffee in quiet rooms full of hum. Week 2. The novelty fades, the new normal rigs itself into place. compasses are genuinely weird at mid-latitudes. Maps of declination, the angle to add or subtract to turn magnetic north into true, are published every year or 5. Now they need updating monthly, then weekly. Some regions see east is north and then, for a day, west is north. Airports publish magvar notes. Runway signs stay the same because painting concrete is not a pastime, but approach plates get bold text. Fisheries biologists report that some spawning runs that use magnetic maps, salmon, eels, stall in a few rivers while proceeding fine in others, depending on how hardwired the migration is. Conservation agencies coordinate to reduce bycatch and habitat disruption during stalled weeks so fish can try again on better nights. Week 3. A flurry of archaeology papers use a technique called archaeomagnetism to date ancient hearths with better precision, taking advantage of the new calibration the excursion provides. When clay heats above a certain temperature and cools, the iron-bearing grains within align with the field at that moment and lock in a direction and intensity. With a good global model, researchers can read those directions like a calendar page. The flip, or near flip, becomes an index, like a barcode printed across centuries that lets you sort pottery and floors and kiln bricks by the last time they saw fire. Week 4. People ask again, could this kill us? A scientist sighs and smiles and says, to be killed by a magnetic field excursion, you would need to fly through amateur solar storm at high latitude every day for years, ignoring dose limits, and even then you'd be likely to worry more about fat, sugar, and cars. The ground is safe. The upper atmosphere is different. Airlines manage that. The biggest realistic risks are technical. A strong storm coupling into a grid that wasn't ready, a satellite sailing through a storm in a bad orientation. Those are solved by operating procedures, not prayers. Months. The planet feels wilder at the edges. Auroras as far south as Texas and Greece every month or 2 when the sun flares. More radio blackouts that strip shortwave bands loud for hours and make ham operators listen and shrug. More stories from people who stayed up late to watch curtains and went to work bleary-eyed and happy. A small surge in sales of surge protectors and Faraday bags for phones that won't help but make owners feel prepared. A few utilities bring forward investments in transformer monitoring that were already on the roadmap, using the scare as leverage to spend wisely. Insurance underwriters quietly add a space weather rider to policies out of habit. Seasons. The field slowly knits. This was always likely. Strong excursions rarely pivot straight into a flip. They wobble, ooze, threaten, and then return. The poles do not pop from north to south like magnets in a hand. They wander across oceans, pause near equators, and lose their shape. In the core, flow reorganizes. Patches of opposite polarity grow and merge. The Venn diagram changes. The dipole grows a spine again. Compasses settle. The Aurora retreats to its usual seats. The South Atlantic Anomaly keeps being a bully, shrinking and swelling, but refusing to leave the playground. Years. People who were 12 when the skies went green binge on videos about the dynamo, the Van Allen belts, the time our ancestors painted caves while auroras lit France. Satellite constellations designed during the excursion carry better shielding and smarter firmware. Airlines build space weather into schedules like they built pandemic buffers into crew planning. The average person remembers the year the compass died as a year they saw the sky breathe. There is a final, quieter layer. Earth writes its memory of this week into rocks. Puddles that bake into bricks, lava flows that cool into basalt. Lake muds that settle in silence all align tiny iron grains to wherever north was that day. North in Labrador, then north in the Baltic, then north somewhere in between. A geologist, 1,000 years from now, will drill a core from a cave floor and read our week like a heartbeat. Wobbles, pauses, a sprint, a long exhale. They will nod and add a line to a timescale that makes our drama look like a hiccup. The point of telling the story hour by hour is not to sell fear. It is to show competence. Humans built a world that depends on electrons dancing to time. The magnetosphere teaches that time can slur and that the sky can open and that our tools are only as good as the humility with which we built backups. A compass is simple and wrong today. A GPS is complicated and right most days. A pilot knows how to fly without either because someone insisted the old skills matter. A grid operator knows when to back off and let a line cool because a table told them so. A scientist knows when to say, "We don't know yet," and how to find out. On the first night, a pilot saw a drift and tapped a dial. On the last night, a child saw Aurora over their house and learned a word that will be with them forever. Between those two touches is civilization doing its job, disappointing the apocalypse and turning an extraordinary week into an ordinary memory.